In a Stanford advanced mathematics class, Karoline Leavitt stepped up to the board, facing a room filled with skeptical students. Some mocked her, assuming she was out of her depth. Professor Davies, known for his strictness, watched with a smirk, expecting her to struggle. However, as Leavitt began writing her solution, the class burst into laughter, dismissing her approach as nonsense. But their laughter soon faded when they realized something shocking: she was on to something. The lecture hall fell silent, not because of the problem's difficulty, but because of who was solving it. Leavitt, the White House press secretary, had no formal background in math, yet she was tackling one of Stanford's toughest calculus problems. When Professor Davies challenged her, she calmly picked up the chalk and faced the board. The class murmured in amusement, convinced she would fail. She studied the problem, a complex network of equations, and when asked if she wanted to quit, she simply smiled. "Why would I quit before I've even begun?" she replied, her confidence unsettling those who doubted her. As she started writing, faint chuckles spread across the room. A student scoffed, assuming she was stalling. Another whispered that she was pretending to be confident but would soon ask for help. However, Leavitt ignored them, moving the chalk across the board with precision. Professor Davies reminded her that even his best students took hours to solve this problem, questioning whether she knew what she was doing. She paused briefly and responded, "If I didn't, I wouldn't have picked up the chalk." The murmurs continued as she solved the problem in an unconventional way, replacing traditional steps with unique transformations that left the class bewildered. At first, her approach seemed absurd. Instead of following standard rules, she connected terms with arrows and used sketches alongside calculations. Students erupted into laughter, believing she was making a joke of the lesson. One even clutched his stomach in laughter, exclaiming that she was drawing the equation. Professor Davies examined her work, clearly skeptical. "Miss Leavitt, I've never seen this approach before. Are you sure you know what you're doing?" he asked. She remained calm and responded, "If I'm wrong, let the problem prove it." Then, she wrote the final step. The laughter grew even louder. Some mocked her, convinced she had made a mistake. "This is nonsense," one student cried. Even Professor Davies dismissed it at first. But then, as he scrutinized the board, his expression shifted. His confidence wavered. Something was off. He compared her solution to the official answer in the textbook, and it matched. The room fell silent. Students, who had ridiculed her moments ago, stared in disbelief. How was this possible? She hadn't followed any standard rules, yet she had arrived at the correct answer. Shock rippled through the class. "Wait, how is that possible?" a student blurted. "She didn't follow any rules." Professor Davies, still in disbelief, asked, "How did you do this?" Leavitt smiled and replied, "I'm not wrong, I'm just different from you." Silence took over the room. Professor Davies flipped through the textbook, searching for an explanation. Students leaned in, some even taking pictures of her work. One hesitantly spoke up. "But how can she be right? She didn't follow the usual method." Leavitt turned to the class, her voice steady. "Mathematics is not limited to just one path," she explained. "Most people are taught to follow a fixed route, but that doesn't mean other paths don't exist." She began writing again, breaking down her thought process. "Instead of following the usual step-by-step process, I looked at the core nature of the problem and tackled it from a different angle." Professor Davies, intrigued, nodded slowly. "You mean you bypassed unnecessary steps and went straight to the essence of the problem?" She nodded. "Exactly. Sometimes, the traditional methods are inefficient. I found a faster way." A student challenged her, asking why this method wasn't in textbooks if it was truly correct. Leavitt replied, "Because people are only taught the safest route, not the most efficient one." Professor Davies furrowed his brow, realizing he had never seen someone challenge traditional problem-solving so boldly and succeed. Finally, he exhaled and admitted, "I have to admit, you've impressed me, Miss Leavitt." Leavitt, however, wasn't looking for approval. "Thank you, Professor, but I'm not here to impress. I just want to show that thinking differently doesn't mean being wrong." The energy in the room had shifted. The same students who had mocked her were now taking notes. Respect filled their gazes. One student hesitantly raised a hand. "Are you saying we should always question everything?" Leavitt chuckled. Not always. But be willing to ask questions. Don't let anyone convince you there's only one way to solve a problem. The people who challenge the norm are the ones who change the world. The class fell into silence, deep in thought. The lecture ended, and Leavitt gathered her things, walking out, leaving behind a group of students who saw the world, and mathematics, differently. Professor Davies stood watching her disappear down the hallway. He let out a deep sigh, not of frustration, but satisfaction. "Maybe," he murmured, "it's time I started thinking differently too."